Madam.
You
please start, madam. Sir, shall we start the session, sir? Jyoti, sir.
Yes, sir, you can start now.
Yes, sir. Yes, sir. Madam, you can start.
Okay, sir. Today was not like yesterday and will never be like tomorrow. So always live life to the fullest and make a most of every day. Wishing you all a very happy and pleasant morning to everyone present here. It is indeed my pleasure to welcome you all on the behalf of SRM Institute of Science and Technology for the day 9, 2 weeks online international faculty development program on the era of change, recent advancement of machine learning in terms of AI and IoT, organized by the Department of Computer Science and Applications. Now I invite our respectful Vice Principal Admin SNH, Dr. J. Dileepan, to deliver the welcome address. Please, sir.
Thank you, madam. A very warm good morning to one and all. It gives me an immense pleasure to you all to welcome you all to this day 9 session of this 2 weeks online international faculty development program. First, I would like to extend my hearty welcome to our chief guest, Mr. Jyoti Perisamy sir, co-founder and chief architect, DSpace.ai, with a deep appreciation for accepting our invitation in spite of his busy schedule. So we are honored to have you as chief guest on this special day, sir. The topic of the today's session is transforming energy sector with artificial intelligence, application of AI in energy efficiency and smart grid. So presently, AI can be used for various applications. So in particular, the energy sector, AI can help transform data collection, storage, and management, and allowing the energy sector to catch up with the times. The application of AI in smart grid provides powerful technical support for digital power network, and the scenarios of AI in smart grid include power supply, power system optimization, and power users behavior analysis and fault diagnosis, etc. So I am sure that today's session will be an eye-opening session for all the participants. So once again, I welcome you all to this wonderful session. Thank you.
Thank you, sir. Now I would like to invite Mr. N. Krishnamurthy, Assistant Professor, MCA, to introduce our chief guest.
Morning, sir. I feel proud and privileged bestowed on my shoulders to introduce the chief guest.
Sir, audio, sir.
Yeah. Good morning. Am I audible?
Yes, sir. Yes, sir.
Yeah. I feel proud and privileged bestowed on my shoulders to introduce the chief guest of today's function, Mr. Jyoti Perisamy sir. Jyoti Perisamy sir is the chief data scientist instructor in University of California, Silicon Valley campus. He is the co-founder and chief AI architect of DeepSphere AI Inc. He is artificial intelligence learning facilitator at MIT Castle and MIT Salon, Boston, MA. He is head of artificial intelligence Xperify Harvard Innovation Lab, Boston, MA. Coming back to his expertise, he has more than 17 plus years of management consulting and end-to-end AI, ML, DL, RPA, NLP experience with Deloitte, EY, and KPMG. He has got more than 100 plus clients across industries in different verticals like healthcare, energy, oil and gas public services. He teaches AI at MIT, head of AI, architect at Xperify Harvard Innovation Lab. He co-innovates industry solution along with SAP America. He published on finance, AI, big data, industrial Internet of Things, cloud, and SAP appliances. He has delivered many research projects on market for AI enterprise services. He is globally recognized as a keynote speaker, and he has delivered more than 50 keynote addresses in various conferences across the globe. Recently, he was invited by the Prime Minister of Dubai, Malaysia, and Montreal. He is a proud alumni of Stanford. Thank you. Thank you for giving me the opportunity. Thank you. Sir, it is indeed a great pleasure for us to invite you. Now the forum is yours, sir. Thank you. Thank you, sir.
Thank you, sir. That's fine, sir. All right. Can you all hear me now?
Yes, sir.
Okay. Okay. Can someone make me as a host so that I have full control?
Yes, madam. Yes, sir. Madam. Sudha, madam.
Okay, sir, I will make sir as a
Sudha,
host.
madam's there, sir. Sudha, madam, there.
Okay, sir. Thank you, madam.
Yes. Yes, sir.
Sir, I had made sir as host, sir.
Okay, madam. Thank you.
Okay, thank you.
All right. No problem. Good morning, everyone. Thank you all. So first, I want to sincerely thank you for the opportunity. I may have spoken many faculty development program or webinar, international conference, whatever you call it. Like, there's many of them I already spoke. Every time when I speak, there's a different audience, different focus, different approach. So I'm really honored, humble to be here and speak in front of you. Thank you. So we want to focus on our today's agendas. We want to start from some kind of foundational understanding. Let's understand, because what I see, there is a lot of people are talking about artificial intelligence, machine learning, deep learning, digital transformation, like intelligent automation, Internet of Things. There are so many different things people are talking. What I feel, but still we are lacking clarity, correct? So when I say lacking clarity, people think machine learning is, the deep learning is an extension to machine learning, which is absolutely wrong. So things like that, there are many things are there. So I thought having a fundamental understanding is important. So we're going to focus on understanding some fundamentals. Second, how does it apply in real world application? Then we dive into energy, okay? So how it works in energy. And then look at some different use cases, correct? Like, such as energy forecasting, control system, energy efficiency, smart grids. Then I want to keep some time for questions in case if there is any, okay? So this is what I want to focus on. And if there is any other specific topic that you want me to talk, definitely I'm willing to talk about it actually. So I do want to start some introduction about the company that I represent. Okay. DeepSphere AI is the company that I represent. I co-founded it along with some other people. So what we do, I'm just going to do a small demo so that you could understand. I would confidently say, based on what I've seen in the market space, correct? There are a lot of people are talking about so many different institutions. Like now I have seen people talking about great learning, correct? So there are many other institutions, people talk about IIT, people talk about many different institutions. I'm absolutely confident. So we may be the first company who build a personalized learning management system at this magnitude, correct? In case if you want to like train 1 million people, we can train tomorrow itself, correct? And it learns and it personalizes, correct? When I say personalizes, the questions, assignment, content, everything will be dynamically created based on how you are learning, your learning ability, your learning speed. So that is what we do as a company. Okay? So that's what we do as a company. I do want to demonstrate a small portion of this so that you could understand. Okay? So if anybody wanted to know about our product, so you can go to our website, which is DS School of AI. So this is basically our website. You can get to see all different things what we do. It's already in the, you can, once you go on the website, you can see there are different options. There is an option for a demo. So this will take you to give you a demo. So I'm just going to use my own credentials so that you can understand. So what I'm trying to say, so this is also part of artificial intelligence. using artificial intelligence, how do you reinvent education? Okay, so this is really critical for a teacher or a faculty or a HOD or a dean or any management person who run an educational institution to understand, because what is going to happen in the future, correct? So right now we have a textbook, we follow the textbook, we teach the textbook, we take assignment quizzes from the textbook. That will change. That will change. There may not be a textbook, correct? So the content will be dynamically created. So this is going to demonstrate how does it work actually, correct? Like, so I'm just trying to log into our system so you can understand how it works. So this is what we as a company built at DeepSphere. Okay, so this is a product we're building. So I'm just going to go to the product so you can understand. So here, what I have a particular course assigned to me, correct? So this course is Advanced Artificial Intelligence for Executive. So it kind of conforms where you are getting into and what the product is about. Say, like, people who just living with concepts, ideas, visions, correct? We build an enterprise-grade product, correct? So our product is built on SAP Litmus. That's the learning management system. So why we build this one? Because it's highly scalable. As I said, if you want to train the entire Tamil Nadu tomorrow, we can. Okay, not 1 people, 2 people, 100 people, 1,000 people. Like, at a millions we can scale. So that's the back end of the platform, and it is hosted on Amazon. Okay, it's 24/7. Anyone, anywhere in the world can access. Anybody, anywhere in the world can access. And third, I said it's completely personalized and it's pretty advanced. Real scale platform on a real scale platform. So once you logged in, it's going to bring up this message. Then you can. So 1 second, it says your internet connection is unstable. All right. So now this will take you to the course that is assigned to you. Okay. So I've been assigned to this course, Advanced Artificial Intelligence. This tells you how much I completed and how much still I'm pending. Okay. So I'm going to continue my learning. That's fine. So here you could see, correct? So the course that is assigned to me, I can launch the course. Okay. So once I launch the course, here you can see this entire thing is personalized. That means we don't hard code any material. Correct? If a teacher wanted to teach data science, if a teacher wanted to teach about certain concept of machine learning, correct? We build the content on the fly. Okay, we build the content on the fly. So here you can see unit 1, and then unit 2, unit 3. So it has all the units. You can see. So what does this mean? I can't go to the other unit until I complete this unit. When I expand this one, it gives you all the things, correct? So here you can see I can complete my learning assignments, assessments, and it's a progress report, recommendation. So this entire thing completely built on natural language processing, using natural language processing on artificial intelligence, correct? So what does this mean? So the current system that what we have in education, if a class of 100 students, all 100 students are treated at the same level. Okay, that means same assignment, same quizzes, same textbook, same study material, same lab, everything. Here it's not that. We give the base material. Once you start learning, we understand how fast you are learning, how well you are learning, and what is your interest. Correct? Based on that, things will be done at a personalized level. Based on that, things will be done at a personalized level. And this also linked to entire lab system. You see this one? You can connect to our GitHub. You can connect to our Google Cloud Colab. You can connect to our use cases. Correct? So for this relevant this one. So these are all directly linked to all our lab and everything that what we do. Right? So at a personalized level. And here you could see assessments. So these assessment, what I'm talking about. So if 100 students are taking assessments, assignments or quizzes, all 100 students will get a different questions. Okay, so there is the knowledge assessment. It could be multiple choice, it could be true or false, it could be match the following, it could be fill in the blanks, or it could be anything. Correct? So that is the assessment. So that's the knowledge assessment. Then the skill assessment, it's a very descriptive. So when I say descriptive, so the questions will be driven based on what you studied, the material that what you studied. So this material what you study could be different than what I study, okay? And this is also completely personalized. Okay, this is also completely personalized. Then the next is reports and recommendation. So reports are based on how you are performing. And this is also dynamically created, and this is very highly personalized. Okay, so there is a participation report, how well you participated, correct? Just because you open the LMS and watching this one doesn't mean that you're participating, correct? So we do, like, we follow your keyboard mouse tracking, correct? Like, whatever you do on the keyboard, that will be tracked. Whatever you do on mouse will be tracked. Anything you do in front of a camera will be tracked. So based on that, we will rate your participation, your progress. Then any feedback the teacher want to give, that also is captured. Okay, that also captured, correct? And then the recommendation. So this recommendation for both student as well as the parent. Okay, for the student as well as the parent. Okay, so there is a recommendation for the students, there's a recommendation for the parents. Right? So the entire thing, what you're looking at here, it's all completely created using artificial intelligence. Right? I can bet there is no single institution in the world come at this far to building anything, everything at personalized level, at a personalized level, and that too each units. Okay, that too each unit. So when you go back, we have different units, correct? So at each unit, you could see the same thing. Okay, this is unit 1. And then you have unit 2. When you go to unit 2, you will see the same thing, correct? So what I'm saying about, this is what we build at a DeepSphere. Okay, and this is the next level of education, next generation for education, next generation's education system. Okay, so going back, so what I was trying to say, so DeepSphere is a company primarily focused on building a personalized learning management platform. Okay, a personalized learning management platform. All right. So as I told you, my focus today, before I jump into energy, okay, so there is a lot of us know concepts, ideas, but then I have more clarity. Okay, so I want to touch some foundations, then I will move on to other topics, right? Like all these energy topics. So let's start some foundation. Okay, my focus today, it's more on industry side, not onto the academic side. Okay, more onto the industry side, not onto the academic side. You have a great faculty like Dr. Dileepan. So he's a great faculty. So he knows a lot of things on a subject from academic perspective. So I am coming from an industry, so I focus more on industry side. So that's my today's focus. So what this session is going to bring you, it's going to bring you a clear view how artificial intelligence applied in a real world. Okay, energy could be one example. And on what framework that we are applying this on an industry. Next, how we apply, like, this on a practical problem solving on the job learning experience. Like, what are the skills we need to apply this on the job learning? And the next is data plays a very dominant role, right? So you can say, I know data well, right? So I've spoken to a lot of people, a lot of faculty, a lot of teachers. They say, I know this well. But if you go close, they have no idea what they're talking, right? So data plays very dominant role. So data means what used to be, we thought it's going to be stored in a table or a file. Now it's not like that. Anything, everything is on data, right? YouTube is a data, Facebook is a data, LinkedIn is a data, Twitter is a data. Correct? Voice is a data, text is a data. Correct? It's amazing. It's amazing to see how data is playing a dominant role in anything that what we do in our life. So the focus is going to be understand how artificial intelligence applied in real world, such as energy. Second, when you want to apply this in energy or any industry, what framework that you use and follow. Third, what are the practical skills someone has to learn so that you could apply this in a real world applications. And third, what skills I have to have so that I can work on data engineering or any on data related activities. So those are the things we are going to focus on. Let's understand the core fundamental building blocks of artificial intelligence. Correct? So this is, in my view, some mystery. Why? Like I said, correct? Everybody knows all these keywords. Correct? All the keywords everybody knows. Correct? Artificial intelligence, machine learning, this, that, they all know this one. But when you ask them, correct? So like I said, we have 107 people in this training, 110 people. Correct? If I ask them, what is deep learning? If anyone give me a clear explanation, correct, I would be very surprised. Okay, what is deep learning? Why? That is the state we are in. Okay, so a lot of us, or most of us, or majority of us simply say deep learning is an extension to machine learning. In my view, absolutely wrong. Absolutely wrong. Correct? That is not right. That is not right. So we are talking something that without knowing a lot of things. Why? That is what you heard from YouTube. That's what you heard from other people. Correct? So it is wrong. So there is lack of knowledge, understanding, clarity on fundamentals, correct? So what we wanted to understand, let's understand all these fundamentals before we go into how it is applied in energy. Because all the terminology what we use, I'm going to talk in energy. At that time, I don't want you to get confused. Okay. So in my view, a lot of people, correct? A lot of people heard this terminology, but 99.9% nobody have clarity. Nobody have clarity. They all misrepresent all these things. As I said, if we ask what is deep learning, majority of people say simply it's an extension to machine learning. Okay. In my view, at least practical view, that is wrong. Okay. That is absolutely wrong. Let's understand the fundamentals of these things. Okay. So I'm sure you have seen these things. You heard about it. You have done this one. So what is speaking, what is reading, writing, cooking, all these things. Okay, I don't have to explain all these things. These are all things what we do on our day-to-day life, correct? We read papers, we speak, we write, we cook, we eat, we drive car. If you are a doctor, you diagnose medical conditions. So what do you call this? So these are our day-to-day life work or things what we do. So these things are kind of an intelligence. These things are kind of an intelligence. Okay, let us understand this better. So driving, who's driving this one? A driver. Okay, so who's driving this one? A driver. So what is driving? Driving is an intelligence. Why do you call driving as an intelligence? Correct? Not anybody can drive. Correct? Why? There is a rules and regulation. There are certain traffic conditions that you have to follow. Okay? There are traffic conditions that you have to follow. If you are not following, then you will get into accidents. Okay, so that is why the driver has to pass and get a license. Correct? So coming back to driving is what? It's an intelligence. Who's doing this one? A driver. What do you call this one? Human intelligence. How did the human get this intelligence? Through a formal or an informal training. Through a formal or an informal training. So when I say formal training, you can go to a driving class, take a driving session, or your father, mother, brother, sister can teach you to learn driving. So that is why it's a formal, informal training. Without a training, it is absolutely impossible for you to drive a car. Okay, there is no way someone can sit in the driving seat and drive a car. You have to go for a driving class. Second, medical diagnosis. Okay, what is this one? An intelligence. When you go to doctor's office, what the doctor's asking for? Okay, are you sick? Do you have headache? Do you have a body pain? Do you have this? Do you have that? Why does the doctor's asking? To conclude, to arrive a state and conclude what disease condition you are in. Okay, what disease condition you are in. So what do you call? That's an intelligence. That is an intelligence. That is an intelligence. Who is performing this one? A doctor. What is this? What is this doctor's like? So technically, what do you call the doctor? A human intelligence. Doctor is a human. It's a human intelligence, right? So how did the doctor gain this kind of intelligence? The doctor went for a formal education. So that education basically got him a lot of training. So through the training, the doctor is able to diagnose this one. The next is a lot of us are all software engineer programmer. So what we do programming. What do you call that? Intelligence. For example, someone knows Java. So can you ask them to code in Scala? They may not be able to code in Scala. Why? They have not taken training. They have not learned Scala. So what does that mean? There's a training component comes into picture. So the training component comes into picture. So what I'm trying to say actually, so the programming, coding, software engineering, these are all kind of intelligence. Who's performing a programmer? What do you call them? Human intelligence. How did this person got the training, got the knowledge, or got the intelligence, either through formal or informal training? So the point what I'm trying to make you understand, whatever we looked at above, reading, writing, coding, cooking, all these things are some kind of an intelligence. Okay. How did we gain this intelligence? Through a formal or an informal training. Who's the person doing this one? Human intelligence. So now what we are talking about, correct? All the things in a summarized way. Okay, so we understand an intelligence, we understand human intelligence. So intelligence, technically, things that what we do on a day-to-day life. If that's performed by a human, it's a human intelligence. If an intelligence occurs without any formal training, if an intelligence occurs without a formal training, then that intelligence, what we call emotional intelligence. When we see funny things, we laugh. When we see funny things, we laugh. How? Because everybody around you are laughing. Okay, people are laughing. Then you laugh based on what things are happening there. To laugh, Do you have to go and take a training? No, you don't have to take a training. You understand the situation, you understand the circumstances, correct? And based on that, you act. And that is basically an emotional intelligence. Okay. So what we learned in intelligence, human intelligence, artificial intelligence. So, sorry, emotional intelligence. So now we are talking about artificial intelligence. So what artificial intelligence means in a practical view. Okay. So creating all the things. Okay. Creating all the things. Okay. Either a human intelligence or an emotional intelligence. Artificially, it's what called artificial intelligence. It's an alternate substitute replacement for human intelligence. Artificial intelligence, by definition, it's an alternate or a substitute or a replacement. Okay. If a faculty is not coming, you have a substitute faculty. If faculties quit or let go, then you have an alternate faculty. If faculty is not performing well, you do replacement. And this alternate substitute in the future could be artificial intelligence. Okay, it may not have to be a human intelligence. So I want you to understand a clear difference between human intelligence, artificial intelligence. Human intelligence, what's happening in SRM right now? SRM teaches students to become a human intelligence, correct? So Dr. Dileepan conducting classes for BCA student, NCA student, all these students. What is he doing? He's creating students to become a human intelligence. Is that what we need in the future? No, that is gone. That is absolutely gone. We need students, instead of becoming a human intelligence, the students should be capable of creating intelligence artificially, such as a doctor artificially, an engineer artificially, an accountant artificially, correct? That is what expected. That is what expected. That's why I told our education system will change. Fundamentally will change. Correct? So what we teach have no meaning in the future. Okay, it has foundation, but what is expected? You don't have to make student to become a doctor. You don't have to make a student to become an engineer. You don't have to make a student to become an accountant, an auditor. Instead, you make students. Okay, you make student create engineer, doctor, accountant, auditor artificially. That is what needed, and that is why the replacement for human intelligence, okay, replacement of human intelligence or a substitute for human intelligence, alternate for human intelligence, what is expected. Okay, I hope you understand the meaning for alternate substitute replacement. I don't have to explain. So by definition, if anyone asks you what's artificial intelligence, you have to tell it's an alternate substitute replacement for a human intelligence. All right. Okay, how do you apply this in real world? Okay? And this is also, in my view, absolute mystery. So many people talk, like, they combine with the big data, IoT, this, that, absolutely not right. Using artificial intelligence, okay? Big data, IoT, all these are all core building blocks, okay? So those are all building blocks. That is not what artificial intelligence, correct? It's nothing to do with artificial intelligence. That could be a building block to build artificial intelligence. How do I take this alternate substitute replacement of human intelligence, apply in my day-to-day life, or apply in a practical problem? In an SRM university, or SRM institute, or any colleges, any hospitals, anything what we do, how do you apply? Only in two forms. Okay, either you can apply in the form of an intelligent automation or data science. Correct? That's the only thing. If anybody talks other than these two, please ignore. Correct? That has no meaning. Correct? Like I said, people say deep learning is an extension of machine learning. It is absolutely wrong. Correct? That is not right. Okay, so same here. Where we apply artificial intelligence, how we apply artificial intelligence, correct? Like, so this is basically what we are talking about. So we understand artificial intelligence is an alternate substitute for human intelligence, correct? How do you apply this in a real world? Only in two forms, either in the form of an intelligent automation or a data science. What's an intelligent automation? An automation that occurs without a human intelligence, without any manual work, okay? So it is more for an industrial automation, okay? So industry never done these things, correct? Talking is different. Practically solving problem, making it happen is different. Correct? So industry never done this one. Industry is ready to do it. Industry is in the process of adopting these kind of automations. Industries in the process of adopting these kind of automations. So using artificial intelligence, we can build an intelligent automation, which is an automation that occurs without any human, no manual work involved. Okay. So we will see what the best example. Second is data science. When I say data science, what I'm talking about is so I don't want to build automation. That means I'm not automating anything, but I want to find something new on what I do. That is data science. Apply science on data. Okay, apply science on data and discover hidden insights. Apply science on data. What kind of science we are talking about? Decision tree, random forest, logistic regression, neural nets, correct? So these are all science and humanities. These are all science and humanities. Applying this science on data extract hidden insights, which we never done in the past. Okay, at this magnitude, correct? So we may have done some researches, we may have done some simple things, correct? So these are the two things using artificial intelligence we can apply, whether it's energy, whether it's oil and gas, or any healthcare, consumer, retail, whatever industry you talk, whatever industry you take. Okay, in those industry, what is that we could do using artificial intelligence? One is you build an intelligent automation. If we don't want to build an intelligent automation, the second option is data science. Okay, so this is what you see a lot of places people are teaching right now. Okay, if you see BTech in data science, BTech in artificial intelligence, okay, or BE with the specialization in intelligent automation data science. Why? So this is what right now industry trend at this point. Correct? Industry wanted to build these kind of things. Okay, industry wanted to build these kind of things. So these are the things industry wanted to do this one. All right. So going back, what we understood actually, an intelligent automation, data science. Okay. The third missing puzzle. Correct. So what we have heard a lot of people, digital transformation. Digital transformation, it's not in a piece of paper you can write and see digital transformation. To build a full-scale digital transformation, you have to have both an intelligent automation, data science working together. So digital transformation basically moves the information from point A to B digitally, no human, no manual work. Correct? Everything flows in a digital form. Everything flows in a digital form. When information flows in a digital form, correct? So how does this information flowing in a digital form? What we need to make that happen? We need an intelligent automation, data science. So when you combine an intelligent automation and data science, you can form digital transformation. Okay. So the point, what I'm trying to summarize and tell you, okay, using artificial intelligence, what can we do for business? What can we do for industry? What can we do for our day-to-day life? You build an intelligent automation. Second, data science. When you combine these two, you form digital transformation. Okay, and intelligent automation means what? So this is the best example to understand an intelligent automation. Some of you, most of you have seen or understood what is this. It's a self-driving autonomous car. Okay, it is a self-driving autonomous car. So here, what we talked about, an intelligent automation means no human, no manual work. There's no human involved. There's no manual work involved. All right. So now, how do we go ahead and build this one? So this is basically where create the intelligent whatever a driver has artificially. So in a driving seat, you have a driver who's sitting. Now we are saying I no need a driver. If that is the case, whatever a driver is doing, starting the car, stopping the car. Okay, when the car is going on a speed, correct? I want to change the lane, correct? Because the car in front of me is not going fast. I want to change the lane. How can I do? So these are the things the driver will do. A driver will stop the car when there's a red light. When the driver will start the car, move the car when there's a green light. The driver will slow down the car when there's a yellow light. So now I don't have a driver sitting in the seat. Instead of a driver, now the machine controls the car. How does the machine? So that is basically what we create that intelligent artificially. Whatever the driver is doing, correct? Stopping the car, moving the car, slowing down the car, changing the lane of the car, and following the rules and regulation of the road, traffic, all of those things. Now we are not dependent on a driver. Now that intelligence is actually trained by the machine which is running inside the car. Correct? So here, what I'm talking about, two things. There's no human, there is no manual work. When I say manual work, so when there is a red light, you don't have to tell anything. You don't have to touch anything. The car itself understands it stops. When there is a green light, you don't have to do anything. Okay, even though you're sitting in the car, you don't have to do anything. The car understands it goes. When there is a yellow light, the car understands it slows down. When there is a car in front of you, but the car is going slow in front of your car, then the car automatically changes the lane. So that's basically an auto change, lane changing. So these functions are now the car itself takes care without a human, and no manual work. And that is why it's called an intelligent automation. An automation occurs without a human, without a manual work. Okay? So please make a note. And such automation, there is nowhere you could see in industry at this magnitude. And this is what industry is trying to do right now. This is what industry is trying to focus on as a revolution. Correct? It's an industrial automation. Correct? It's an industrial automation. You are automating not just piece of software. It is an equipment. Correct? The car is an equipment. You are automating that on a full scale without a human. Correct? So this is basically the best way to understand what is an intelligent automation. Correct? That is the number one. Like I said, don't go machine learning. Like what I have seen many cases. Correct? So there are curriculum that I looked at. the entire 2 semesters they're teaching Python. I don't know what they're teaching in Python. So Python is just like, maybe 5-6% of the curriculum that someone has to learn, right? Understanding all these deep concepts and working towards building an industrial automation is what is needed, right? So I have seen, I don't want to comment anything, but I was just laughing by myself, like, they're teaching 2 semester Python and then basic things, and that course is called BTech in Artificial Intelligence and Specialization in Data Science, right? So teach people understanding all this advanced concept, which is really important, right? The second point is what we understand data science, correct? And this is also a mistake. There is no clear mean of understanding what is this, correct? So basically, when you go to a doctor's office, what is the doctor's doing? The doctor is asking series of questions. What is the doctor asking? Or you say, yes, what kind of symptoms do you have, correct? Such as headache, vomiting, like body pain, fever. So the doctor will ask all this question. Why the doctor is asking? The doctor is trying to discover something from you. Based on what you say, the doctors come to a conclusion on your medical condition or your disease state, what state of the disease you are in, okay? So that the doctor can move forward with his medical procedures, correct? So take that as an example. So the question that what the doctor is asking is basically trying to discover your disease condition or your disease state where you are. So all those things the doctor is trying to discover. So that is a human side of it. Now I don't need a doctor. I can do the same thing using machine learning models. Okay, using machine learning models. Understand? In the previous example, we are automating an equipment. What equipment? A car. So the car is fully automated. In this approach of data science, I'm not automating a car. Instead, I'm doing something what a doctor does. Okay, when you go to a doctor's office, the doctor's asking series of question, correct? Like I said, what do you have headache? Do you have body pain? Did he eat? Did he drink? Did he like vomit? So the doctor's asking all this question to discover a hidden disease state or disease condition from your body, correct? Or the doctor sending you for a medical procedure, testing blood and all those things, correct? Similarly, you want to discover, correct, hidden insights and data without any human. Okay, without a human, how can you do? That is what data science. So here I'm not automating a piece of equipment or a process, correct? Instead, I am trying to discover something hidden inside on a data, okay? Something hidden inside on a data. So here I'm applying science on data. When I apply science on data, what happens? I can extract. As I said, you don't need a doctor who can diagnose and tell what disease state, what disease condition you are in, okay? Instead, based on your data sets, correct? Your demographic data, clinical data, behavioral data, life, personal, all this data, I can arrive what disease condition, what disease state you are in, correct? So this is basically another approach of bringing artificial intelligence to business or an industry. So this is just an example, okay? So the best way to understand, when you go to doctor's office, the doctor diagnosing is coming up with how long you can stay or when you can discharge, when you can readmit it, all the things. Now what I'm talking about, I don't need a doctor. We can discover this without a human intelligence that such as a doctor. How can I do? I'm going to apply the machine learning models. Okay, what kind of model? It could be a statistical based data analysis model, or it could be neuron based models kind. So either it could be simple decision tree or a logistic regression or any other neural network, right? So I can apply all these things and find out how long a patient can stay, when the patient can be readmitted, when the patient can be discharged, how the patient is behaving. So these things I can discover without a human intelligence using data science. And this is basically applying science and data, extract hidden insights. Okay? All right. So these are the two things we discussed. The next is digital transformation. I'm going to skip this one. So the best way to understand digital transformation, in the US, you have a food delivery service called DoorDash, and also taxi service called Uber. I'm very sure most of you are familiar. In case if it is not similar products, this similar platform, there could be a different platform back in India. Right? So if you look at here, in Uber, all you are telling, your pickup location, drop-off location. That's how you are telling. The rest, everything, it's completely controlled by the platform, right? The application that what you are using. So what this application is doing actually, it understands based on your input, like such as from where you want to pick up, where you want to drop off.
It does everything automatically. What it does, it calculates the rate, it calculates the time, it calculates the distance. In case if there's any traffic or any accident, it does forecast. It does an alternate route, correct? So if you see here, it's a mix of an intelligent automation, data science, okay? So when I say intelligent automation, the end-to-end process. So from the time you picked up, the time you dropped off, charging your credit card, it's all fully automated. There is no manual work. There is no manual work. There is no human involved, correct? When I say automation, it takes your credit card information, it processes the payment, it gives you the receipt, and it confirms that it's been paid, and it closes the transaction. That's an automation. That is an automation. When you're on the car, correct? If there's any accident, if there's any slow traffic, so what it does a reforecast. That's a data science. That's a data science, correct? So as we discussed about a digital transformation, it's a combination of intelligent automation, data science, which forms a digital transformation. And that is what we looked at here, correct? So an intelligent automation, data science, when I combine these two, it forms the digital transformation. It forms the digital transformation. All right. So what we understood so far, how artificial intelligence applied in practical real world. Okay. So no matter what you heard from outside, what you learned so far, and this is reality. This is happening, things that are happening in industry, correct? As a theory, as a concept, you may have studied many things, correct? When you go on a practical world, all these things may not be applicable, like whatever theory you studied, but this is what industry is looking from. So tomorrow, if you're going to look for a job, if you want to do some research projects, correct? Your research project, it could be around any one of these areas. It could be an intelligent automation, or it could be data science, or digital transformation. Keep in mind, whether it's an intelligent automation, data science, you still have to build the algorithms, correct? You still have to build your own algorithms if you don't want to use any pre-trained models or any algorithm that's already been developed, correct? So there is more academic also involved. I'm not saying I took academic completely out. There is still an academic concept involved, correct? But the majority of the need in industry, an expert who can understand all these moving parts and help to build or solve these kind of complex problems. Like I said, correct? So when you go to a doctor, the doctor is asking series of questions, correct? So those questions could be, correct? So whether you had like this, what kind of symptoms you have, like a fever, headache, all those things. What is the reason for the doctor asking? The doctor wanted to come to a conclusion. So now what I'm saying, correct? Instead of the doctor asking these questions, the machine can ask this question. The machine can arrive at a conclusion. The machine can come to a recommendation. Right? All it's possible. All it's possible. That is what the need. Those falls under data science. Those falls under data science. So think in that way. Think in that way. All right. So what we covered so far. Okay? How do you apply artificial intelligence in a real world? All right. If I want to build this one, how can I build? And this is where machine learning comes into picture. Okay, this is where machine learning comes into picture. So if you wanted to build all these things, okay, how can I build this? Okay, if I wanted to build this one, how can I build this? So this is where you have to understand machine learning. Okay, so what is machine learning? Machine learning, it's the art of teaching machine. It's the art of teaching machine. So what is Dr. Dileepan is doing? I don't know whether he's teaching or not, correct? But his job, vice principal. Before that, he may be a HOD. Before that, he may be a teacher. So what was he teaching? He was teaching the student. What was he teaching? Actually, he's teaching the student to become human intelligence, correct? So he's teaching either, I don't know, it's like, any programming or any, like, computing. So a lot of different things you may have thought, correct? So point is, we teach students so that the student become a human intelligence. Now what we are saying, I'm not saying that you don't need to teach the student. You can still teach the student, but teach the student how the student can teach machine, right? How the students can teach the machine. So point is, if you want to build artificially created intelligence, okay, if you want to create intelligence artificially in the form of digital transformation, in the form of data science, in the form of intelligent automation, the only option is teach the machine. The only option is teach the machine. So that is when human is out of the picture. Human is out of the picture. So if you teach the human, then the human will become a human intelligence, correct? So instead, you make a human as a human intelligence. You make human as an intelligence which creates other intelligence artificially, such as doctors, engineers, or lawyers, advocates, correct? And that is what the need right now. So if you want to build intelligence artificially, the best way to do is teach the machine. How do I teach the machine? These are the techniques. Okay. How do we teach the machine? These are the techniques. Again, it's so much mystery here. Okay. So much mystery here. So what the slide represents, two key concepts. One is, so as I told you, by definition, By definition, when people say machine learning, it is a concept. It is the art of teaching, training, deploying machines. That is what machine learning means. Okay, it does not represent any technical terms. It does not represent any architecture. It does not represent anything on a specific systems or an application artifacts. It is a concept. What is machine learning tells you? It tells you you are teaching a machine, training a machine, deploying a machine models. That's all it tells you. But how the machine is learning, what is the machine learning? That's what differentiates further. Okay. So what you see here, so this is represents two things. One is how the machine is learning. Second, what the machine is learning. Understand? Simply telling machine learning, it's mean nothing. It means nothing. It is a concept. It is a concept, correct? It does not tell. All right. There are two key components we have to understand. It is absolutely important. As I said, it is a mystery. Okay, it is a mystery. So unfortunate situation, and that is how it is. Okay, like I said, if you watch 100 YouTube videos, 99.9% will tell the same thing. Why? So one follows the others. Okay, one follows the others. So here we are talking about how the machine is learning and what the machine is learning. So the first two, this is how, and this is what, this is what, this is what. So these are all, these three are what the machine is learning, and these two, how is machine learning. So the yellow box represent the machine learning using statistical approach. Okay, using statistical approach. This box represent the deep learning represent the machine is learning using neuron approach. Okay, not a statistical approach, neuron based learning approach. So the learning technique, the learning methodology, the learning technique, the learning methodology is differs. Okay, here it very statistical based learning approach. Here neuron based learning approach. And what the machine is learning, like a human. Okay, like a human, what we do as a human. Okay, if you look at 24 hours, in the 24 hours, either we read, we write, correct? So you will, like when I say read, write, speak, correct? Read, write, speak. If anyone tells, I don't read, I don't write, I don't speak, I would be surprised. Any human, including a child, okay? You take what they do on their life, they read, they write, and speak. How do you make the machine to do the same thing? That is what natural language processing. If we want to teach the machine where the machine can understand both spoken and written languages, that is natural language processing. Okay, so what I'm talking about, yeah, technique, how the machine is going to learn, correct? How the machine is learning. Second, what the machine is going to learn. So here I'm talking about what the machine is going to learn. The machine is going to, in this case, correct? Like I told you, you take anybody, okay, whether it's a child or an adult or like, old people, we all read, write, speak on a daily basis. If I want to make the machine to do the same thing, why? I want to have an alternate to human intelligence. I want to have an alternate to, like, human intelligence, substitute, replace to a human intelligence. How can I do this one? And that is where natural language processing comes into picture, correct? I want to have an alternate. Okay, instead of a human, now I want the machine to write. Instead of a human, I want a machine to speak. Instead of a human, I want a machine to listen. Correct? How can I do? So that is basically natural language processing. Under natural language processing, the machine learns about languages such as, correct, spoken languages, written languages. Can I implement natural language processing yet using a deep learning model? Answer is yes. You can implement natural language processing applications using a deep learning model. And that is why I said it is very important for you to understand, correct? As I said, there's a lot of lack of clarity here. People just think, okay, I know this, I know that, correct? That's nonsense, correct? So getting very clear view on is most important. So one is what the machine is learning and how the machine is learning. So the machine is learning languages, how the machine is learning using a deep learning model, correct? All right. So we understand under natural language processing, the machine learns about languages, both spoken and written. Second, on a day-to-day basis, you ask as a human, correct? What we do, we look at objects, we watch videos, we watch television, we see people, we do things, correct? We walk, correct? We drive. So what is happening all this time? Vision, correct? We see something. When I see something, we take immediate action, correct? So when I see something in front of me, I take an immediate action, correct? So when I see something in front of me, I take an immediate action. So how does it possible? That's my vision. So similarly, if I want to teach the machine where the machine can understand what I understand, correct? When I see a human, I understand it's a human. When I see a baby in front of me, I understand it's a baby. When I see an animal in front of me, I understand it's an animal. When I see some object in front of me, I understand it's an object. How do I do the same thing for a machine to do the machine to understand? Right? Instead of a human, I want a machine to understand this is animal, this is baby, this is dog, this is an object. How can I do this one? That is what computer vision. Under computer vision, the machine learns and understands about objects, images, videos, and etc. Correct? So like a human, you compare yourself. Correct? The goal is what? Keep repeating yourself. Correct? Artificial intelligence is an alternate substitute replaced for human intelligence. Correct? So that means what? Anything we do, we need a replacement. Anything we do, we need an alternate. Anything we do, we need a substitute. And that is what these are all. So under computer vision, okay, under computer vision, the machine learns about objects. So that is what you see. Facial recognition, object detection, gender detection, animal detection, this detection, correct? You see all those things, correct? How does that possible? How does it possible? You train and teach the machine. You train and teach the machine, correct? So that the machine can understand all the things. All right. You can use deep learning models. Okay. You can use deep learning models to build computer vision based application. You build computer vision based application. Okay, to build a computer vision applications, I can use deep learning models. Correct? So what we understood, two key concepts. One is language processing. Second, computer vision. Correct? Natural language processing. Whatever I do as a human, I want to do the machine. What I'm doing right now, I'm reading and writing, and I'm speaking. I want the machine to read, machine to write, machine to speak. How can I do natural language processing? So as a human, I can see any objects in front of me. I can walk. Okay, so whatever I see, whatever I'm seeing in front of me, so based on that, I can take an action. I'm doing something. So those are all vision, my vision. Similarly, I want a machine to do the same thing. When a machine sees an object, it has to take an action. For example, the self-driving car, on a constant stream, the car is going on a road. Now it sees a red condition. The action it's supposed to take, it has to stop. Okay, so how you as a driver is doing? Now I want to teach the machine. So that is basically computer vision. Okay, the machine understands there's a red light, there's an animal, there's a dog, I'm going to stop. So that is computer vision. So both natural language processing, computer vision, you can implement, we can build using deep learning. The third is robotic process automation. This is a mystery, correct? So a lot of companies, I don't want to name them, correct? They simply say that, oh, we do artificial intelligence, build robotic process automation. Two things. And instruction-driven automation is different. Like company like UiPath, Blue Prism, Automation Anywhere. So these companies are they call themselves RPA companies, robotic process automation. Correct? So building an instruction-driven robotic process automation is different. Building a self-learning RPA is different. When I say self-learning means that is where artificial intelligence comes into picture. Okay. So point what I'm trying to make. So we understood we can teach the machine language. We understood we can teach the machine about a vision. We can also teach the machine about a business process. Correct? When I say business process, I want to cook rice. Okay. There are a sequence of steps we can do. The steps are take rice, clean the rice, put the rice in the container, okay, and put it on a microwave and heat for some time and watch it and do such things. Right? You see, there's the sequence of process. So these process I want to automate. How can I automate this one? So you need to teach the machine. How do we teach the machine? And that is where robotic process automation comes into picture. Under robotic process automation, the machine learns about process. A process is nothing but sequence of steps and take an action in every step. And based on the outcome of the previous step, the next step will be performed. Correct? So there is, when you say process, there is sequence of steps. Each step has its input and its output. So one input will goes to an output to the next process like this. Correct? So if you want to teach the machine where the machine can understand sequence of tasks to be performed, correct? And that falls under robotic process automation. You can implement robotic process automation using deep learning. Okay, so what we studied right now, what we understood, what we are going to teach the machine. You can teach the machine, you can build applications using natural language processing, computer vision, robotic process automation. So, okay, so from industry perspective, you can build applications on natural language processing, computer vision, robotic process automation. All right. Now, how do I build this application? You have two options. Option A, use statistical based learning methodology. Second, neuron-based learning methodology. Keep in mind, whether it's a computer vision or a natural language processing, robotic process automation, the machine has to learn. Okay, simple. You are a human, has to learn, correct? However way you are learning, correct? If you are learning, so for example, I understand Tamil, I speak Tamil. Okay, am I able to read Spanish magazine or a Spanish language? Can I speak Spanish language? No. Why? I'm not trained. If I want to speak Spanish, then I have to train. Same thing here. Okay, so that falls under natural language processing. If you want a machine to speak, read, write, then you have to train the machine. How do we train the machine? Then I have to choose the training methodology. The training methodology, option A, statistical based approach. Option B, neuron based approach. Okay. Architecturally, there are a lot of difference between these two, which we are going to see. We are going to see this one. So under statistical based learning approach, you see supervised, unsupervised reinforcement. Correct? As I said, if we go and see YouTube videos and all the things, there's so many different versions of supervised, unsupervised reinforcement, correct? But there's no clarity. There is no clarity. All right. The second is deep learning. Deep learning has a different architecture. It has input layer, hidden layer, output layer. Like there are many other components which I'm going to talk about. Correct? Like so, we will see when we get to the energy use case. So the architecture of a statistical based learning methodology, learning approach, learning technique is different than a neuron based learning approach, learning methodology, learning technique. Correct? So please do not get confused. Correct? So this is one of the things that what I see in industry. People simply say deep learning is an extension of machine learning. Not at all true, right? Why? Machine learning, by definition, it's just a concept. It tells you teach the machine, train the machine, deploy the machine. It doesn't tell you how the machine is going to learn. What is the underlying architecture component? What are the different technique it follows, correct? It doesn't dictate that one. Which is dictates these guys. Supervised, unsupervised reinforcement, that has an architectural framework, that has the underlying component where how the machine is going to learn. Same thing, deep learning. So what is the difference between these two? Right? What is the difference between these two? And that is what people are expecting. Under supervised, unsupervised reinforcement, typically the machine learns based on statistical learning and methodology learning approach. Under deep learning, the machine learns based on neuron-based approach. Correct? All right. So what we studied so far, correct? In summary, the goal is to create intelligence artificially. The goal is to create intelligent artificially. How to create intelligent artificially? Teach the machine. How do we teach the machine? Correct? So that is where you have different approaches to be followed. Okay. So this is what we kind of summarized based on what we discussed so far. All right. If you want to be a subject matter expert, okay, whether in the field of teaching or as a industry professionals, correct? So you have to understand these all five, whether I call technical concepts or any other way you want to represent this fine, you have to master all these files, correct? So if you understand how to build applications on natural language processing, robotic process automation, computer vision, using or implementing deep learning models or supervise these models, then you have more clarity. Okay, you have more clarity, then it will be much easier to articulate all the things. All right, so this is what I call at the beginning missing puzzles or mystery. Okay, this is the mystery. So this concludes my introductory session. I'm going to move on to energy right now. Okay, so now what we understood so far, what is intelligence, what is human intelligence, what is emotional intelligence, artificial intelligence. We understand that one. How artificial intelligence applied in industry, that also we understood in form of an intelligent automation, data science. When you combine these two, digital transformation, that is how you apply or build intelligence artificially in the industry side. Okay. Second, third, what we understood, how can I do this then? Okay. How can I build an intelligent automation? How can I build a data science? How can I form a digital transformation? So then we have to teach the machine, not a human. So that is when machine learning comes into picture. Second, what we learned, okay, under the machine learning, what to teach the machine, how to teach the machine, what to teach language, vision, process, natural language, computer vision, robotic process automation. That is what to teach the machine. How to teach the machine, either a statistical based learning methodology technique or a neuron based learning methodology technique. Each one has its own story to tell. I don't have time to go in depth on all those things. Okay? So if you want to be a good subject matter expert, if you want to teach the student, okay, with real good solid knowledge, we must have to master these things before we go anything else. Correct? At least we should build 1 or 2 applications on each of this. Okay, 1 or 2 applications. Okay, so one application using deep learning model, one application using statistical based learning methodology models. Correct? If we implement that for computer vision, natural language processing, robotic process automation, you understand the art of artificial intelligence. Right? All right. So with that said, I'm going to move on to energy efficiency, energy benchmarking. Like I said, this is more into it. I don't want to spend too much time on this one. So then we lose the focus on the other side. All right. So now what I want to do, I wanted to cover about how does this apply in energy. So these are things that I have done in the real world. Okay, these are things that I have done in real world. So before we go, I just wanted to show you something that what we have done. Okay, this is my data studio. It's in Google Cloud. Okay, it's in Google Cloud. So what you're looking at right now, I'm not using the actual real data sets. Okay, it is a data sets that we customize. Okay, so what you're looking at actually in energy world. So this is not a hard-coded thing. Currently, you see, it is coming from the product is Data Studio. It's on Google Cloud. Correct? So that's what we are using actually. And so here, what I wanted to talk about, how does these are all working in a real world? Okay, these are all working in a real world. So how much energy is being consumed? Okay, how much energy is being consumed? Correct? So you can analyze this one. It's a very complex, large data sets. Correct? It's a very complex, large data sets. You can look at by geography, correct? By city, state, zip code, whatever way you want to look at, you can look at. So here you can see from different data. You can see by year, you can see by month, you can see by week, you can see by city, you can see by customer type. Correct? So you can select different customer. Where it's a residential customer, how much energy has been consumed? Correct? How much energy has been consumed? So you can analyze this one. Okay, so this is basically what I'm talking about. Like, it tells you how much energy has been consumed. Correct? So how much energy has been consumed? You can see them. Like I said, all these are all real time. Correct? It's not a hard-coded thing where I'm just trying to do this one. So this is how much energy has been consumed. How much energy has been consumed. All right. The second is how much energy I need based on the consumption, how much I'm using, how much energy I need. Okay. So I can look at in months in a particular city. Okay. Or I can see different patterns. Can't like I see this one. So I can look at per a month how much I need. In a city, how much I need. You could add many parameters. I'm just giving examples. I'm just giving you examples. Correct? So this is basically I'm talking about like on a month. Okay, so this is what like on a particular month. What's the demand? Okay, what is the demand? All right. So this is another way to look at analyze data. I can look at years as well. Okay, I can look at like different patterns. Okay, so I can look at trend. Okay, is there any energy trend? All right, so this is some kind of trend that I'm seeing for the last 12 months. Okay, is there any seasonal patterns? Is there any irregularity? Is there any cyclic things that occurs? Okay, so I can analyze all of those. I can analyze all of those things. Correct? So we will cover all the topics like so trend, seasonal, irregularity, cyclic, all those things. Correct? Second, variance. I'm sure these are all practical example I'm talking, correct? When I say variance, what is the plan? What is the demand? How much I produced, correct? Like basically, so I planned for production of this much energy, but the energy consumption is higher than what I planned for, correct? So it tells the variance. Correct? You can look at variance by month. Each month, how much the energy is consumed, how much the variance. Correct? You can look at this one. You can look at this one. All right. So all these things basically like so what I'm talking about like so it's a different type of analyzing data, energy data, live data. You can see all the things. Correct? So this is the next application that what we build using the energy data. The next is different machine learning model that's been implemented. Okay. So this is the different machine learning model that has been implemented. Okay, so what this basically tells, like this, what I wanted to demonstrate here. So how do we optimize my energy? Okay, how do we optimize my energy? So this is energy optimization, correct? Energy optimization. So this is kind of trying to predict, okay, trying to predict, like so you have energy consumption, you have energy demand, and you also have variance, correct? When I say variance, so this is how much you produced, and this is what you used, and this is the difference, correct? So this is what the difference is. So one is planned, one is actual, and the variance. So now, how do I optimize? Okay, to optimize this, we used machine learning models, right? We used machine learning models to predict how much energy I'm going to consume. Based on the consumption, I'm going to do a demand forecast. This is how much I wanted to produce. And then we want to do any analysis on that one, right? So this is a machine learning model that what we implemented in terms of energy protection, energy consumption, how much you want to produce, how much you want to consume. So keep in mind, based on all the data that what you looked at. So this is the data that has been energy consumed, how much energy has been consumed. All right. The second is how much energy is actually needed. Okay, that's a demand. And this is the variance, correct? This is the variance. So the demand is this, but the usage is low, high, correct? Like this. Now, how do I optimize? How do I optimize this one? And the last one is smart grid financial forecast. A smart grid financial forecast. Based on the meter data, you do forecast. Okay, so when I say forecast, you find out what is the by plant. Okay, by plant, you can do forecast. You see this one, there are different plants. So you can select a plant and see how much revenue that plant is going to give. So this has both actual and prediction. Okay, so you can predict your net income, operating cost, cost of goods sold, amount that you spend on capital, right? So it does everything. Okay, it does. So these are all full-scale machine learning model prediction. Okay, these are all full-scale machine learning model prediction. So what are you trying to say? What I'm trying to say actually, I'm trying to say that. So these type of applications, okay, these type of application you can build using artificial intelligence, such as in the form of data science. Correct? So what am I going to call these things? Do you call this as an automation? It has some automation component, but majority of them in this case, data science. Majority of them in this case, data science. Correct? So what we are analyzing energy consumption, how much energy is being consumed. What is the demand? We also understand what's the demand. Third, what is the variance? Based on usage and demand, what is the variance? Correct? All right. How do I optimize? Okay? How do I optimize this one? So when I say optimize, I don't want to produce too much energy. I don't want to produce less. I want to produce optimal energy. At the same time, I also want to find a way to reduce energy consumption. How can I do this one? The next is based on the meter data. I want to do forecast. What I'm forecasting my revenue. I'm forecasting my capital spend. I'm forecasting my cost. I'm forecasting my margins. Correct? So what is the margin I'm going to get? Correct? So how do we forecast these things? Based on the meter data, based on your pricing. Correct? If my energy cost is going to be this much, correct? So I'm going to add this much cash flow, or I'm going to get this much revenue. If I'm going to reduce my energy cost to this much, then what is the impact to my cash flow? So like this, you can do a lot of different scenario analysis and forecasting. So this is an actual application that we built on Google Cloud. Okay, on Google Cloud, the product that what we used for to analyze this one, Data Studio. Data Studio, you can see this one. All right. So here, now what we want to understand how we implemented this entire solutions. Okay, let's go into deeper. All right. So here we are going to focus on understanding and implementation, data and business process. The first step is understand the business side. Second step is understand the data. Third step is understand how do we implement this one. Okay. So keep in mind, now we are getting into implementing artificial intelligence in the form of data science in energy. Okay, in energy. Let's start from here. All right. So what is involved in this entire thing? So we will be talking about understanding about Google products. Google products means I'm talking about I told you about Data Studio. That's a Google product. Colab, so where the codes are written. Okay, so we have the actual code. So that is in GitHub. Okay, so the code that what is running underneath, so that's in my GitHub. Okay? So you could see, so this is in my GitHub. So here I have all the code block. Okay, all the code block. So you can see all the different industry use cases what we have done. Okay, so all the different industry use cases that what we done actually. So you can see there are different industry use cases. So you can look for energy. So those are the different use cases. Okay, so so there are different use cases. Like I said, we have done. So this is an energy use case. So here I have a machine learning model as well as a deep learning model. If I want to, like I said, one is a statistical based learning approach, neuron based learning approach. So if I go to my deep learning model, so this is basically different things: problem statement, data set, model architecture, model implementation source code. Model implementation source code. So this is what it is. Okay? So this will give you the actual source code. Okay, so this runs in the actual, right now I'm using GitHub. The code is actually written, compiled, deployed in Google Cloud. Okay, so you could see everything that is involved. It's all here. Okay, so this is the actual code block that's written and deployed. Energy demand forecasting using RMP model. Correct. So like this, you can look at all different models that what we implemented here. So what I'm trying to say, okay, so this entire process of what you're looking at right now. Okay, 1 second. So this is a simple machine learning model, correct? Like, and this is basically a simple machine learning model that has been implemented. So you can see this one. So I'm going back here. So what I'm trying to explain to you. So the underlying technology that is involved in this whole project, okay? It includes big data and IoT platform. And it also includes AI platform. It also includes a computing platform, correct? It also includes a computing platform. So the IoT and big data platform, it's a combination of Google Cloud as well as AWS. Okay, so that is an important thing. All right. So the finance, it's coming from SAP. Okay, coming from SAP. So if you want to build at a scale, for your learning studying, it's different. Correct? For your learning studying is different. If you want to build this at a scale, then definitely you have to have different approach. You have to have different approach. So here, what I'm talking about, the technology that what you used for energy demand forecasting. Okay. All these technologies are working together. So we have Google Cloud, Google Colab, AWS, SAP, GitHub, all of them are working. Okay, so why we need SAP? So that's where I get finance, supply chain, operational, and other data sets. Correct? So if I want to do my financial forecast, correct, such as how much revenue I'm going to save, how much energy I'm going to, like, what is going to be my energy cost, correct? So for all those, I need a data. Where am I getting this data? So that is coming from SAP. How do we read the meter data? I need an IoT device. Okay, I need a sensor. Correct? How can I get those things? So that's basically part of Google Cloud, Colabs, the AI platform, Google Cloud. And how do we code Colabs? Where do we maintain the source code? GitHub. Okay? So it's a combination of technology to make this work. All right. So as I said, our focus is going to be understanding the business process, understanding the data, understanding the implementation, and the technology behind all the things is these things. Okay? This is the technology involved. All right. Now let's move on. Okay. So here, how does the actual business process looks? Correct. So how does the process looks? The end-to-end process. Correct. So typically, the energy is being generated. Then the transformer. Correct. So the generated energy is being transmission, distribution. Okay, and then the consumption. So if you look at energy, so what is involved in energy? So there is the generation, transmission, distribution, consumption. Again, these are all high-level view. Okay, you generate, transform, distribute, and use. Okay, when I say use, that is where it comes to either it's a residential or an industrial, etc. Right? So you generate the energy either through water or any other sources. You generate the energy. Once you generate the energy, you transform the energy. Once you transform the energy, then distribute the energy to different purpose. The purpose could be residential, or it could be commercial, or it could be industrial, etc. So this is a high-level process. Okay, this is a high-level process. So now the objective. Okay, what it is, supply and demand. Okay, so what is the supply and what is the demand? Okay, so if this is not optimized. The supply and demand is not optimized. Either you're wasting a lot of energy or you don't have energy consumed, correct? So that is what happens, correct? So we don't want this kind of situation, okay? So this is the underlying problem we have undertaken to solve. Okay, optimize the production, okay? Optimize the production, energy generation based on the market demand, based on the need. Optimize the consumption based on the supply, correct? So based on the supply, okay? So how do we optimize this one? Reduce the capital spend, reduce the operating costs. So these are all the objectives for us to undertake this project. Okay, to undertake this project. So what are the objectives? These are the objectives. Number one, optimize the demand, correct? So optimize the demand, optimize the supply. So this is basically one of the number one driving factor. So this is just an example, correct? Like typically how much energy has been consumed on an appliances, correct? So if you look at our house, we have television, we have dishwasher, we have fan, we have coffee maker, we have microwave, etc. How much this is consumed? This is a sample data, correct? This is sample data. So we need this kind of usage data, how much energy is being consumed, so that we can understand the overall consumption per day, per week, per month. We understand what it is, correct? So this is one way to look at it, correct? So one way to look at it, how it is the energy is being consumed. All right. So how do I know all this energy consumption? Okay, so this is basically what we looked at: energy generation, distribution, consumption. So from the house, okay, either using sensors or some mechanism, you can read and understand how much it's been consumed. So we had sample data which we collected from, we chose a specific city to do this kind of pilot work, right? So we were able to collect and understand how much energy has been consumed, okay, in that city. So now, once we have that kind of data set, then we have to calculate this one. It's a 5-step process, how the energy cost. So what is the energy cost? So first identify the number of appliances devices used, correct? In a household, what are the different appliances used? We identified that one. Calculate the energy consumption of each appliances devices per hour. How much is consumed per hour, then per day, then per month, then calculate the energy cost, correct? So how we arrive the energy cost, this is what it is, correct? So these are all basically like, how did we calculate the energy cost? I'm just giving some background so that you can understand, correct? So number one, our goal is to understand how much energy is being consumed in a residential house, correct? It's not in a commercial building. I'm just taking a simple example so that you could understand. So when energy is distributed, and see how much it's been consumed, correct? So is there any correlation? I'm distributing 100 volts. How much I'm going to consume? I'm going to consume 110 volts. Is it possible? No. Okay. So like this, I have to arrive instead how much energy is being consumed. We did that. And we calculated energy cost. Like I explained, it's a 5-step process. So how much number of appliances used, and each appliance, how much is consuming per hour, per day, per month. Then based on that, we arrive the energy cost per month. All right. So now we are talking about I want to do a forecast. So I understand how much energy has been consumed. Okay, I understand how much energy has been consumed. Okay, so now I'm asking what to forecast. Okay, all right. So we are going to do energy forecasting. Okay, energy consumption forecasting. Okay, so what to forecast? What insights business wanted to know to plan well? What are the forecasting scenarios we try to implement, correct? So what are different forecasting scenarios we want to implement? So that is also another important key points. So what I'm trying to say, these are all intent drives to building your machine learning models, okay? So we need a model which predicts the volume. We need a model which understands how much, okay, capital I'm going to spend. Okay, I need to come up pricing, correct? What would be the price that I can get this kind of energy cost, correct? So like this, all these things we have to predict. Okay, we have to predict. So we have 3 different goals to achieve. Number one, optimize the production based on the market demand by day or a season or a work hour and others. Okay, on Sunday, how much energy we have to produce? On Monday, how much energy we have to produce? On holiday, how much energy I have to produce? That is what this objective. So the number one problem, what they ask us to do, find out how much energy we have to produce, correct? So that is part of the forecasting. That is part of the forecasting. All right. How much energy we wanted to produce. So either on a weekday or a weekend or a holiday or any special seasons, correct? Like Christmas, that's a special season. New Year, that's a special season, correct? So like this, they ask us to find out this one. Second, how much has been consumed? Tell me the trend. Okay, tell me the supply. Tell me the labor cost involved. How much loss has occurred? How much theft has occurred? Okay? All the things they ask us to find out. Okay. The next is financial models. Financial models involves understanding pricing, understanding capital spend, how much cash flow, correct? My energy bill, like energy rate. Let's assume my energy rate, okay, per volt is 55 cents. If I'm going to increase to 57 cents, what is my cash flow? Okay, how much margin I'm going to make? How much profit I'm going to make? What is my revenue is going to look like, correct? So all the things, correct? If I'm going to reduce my energy consumption, what am I going to lose? If I'm going to increase my energy demand, what is my capital spend is going to look like? All the things they ask us to find out. So there are three key focus area. One is optimize the energy generation, okay, based on a day, based on a season, based on holidays, etc. Second, more on the financial side. Third, more on the operation side, more on the operational side. So these are the three key driving factors for us to do energy forecast. All right, what are the data we used for? Okay, it is important. We had a time data, we had a weather data, we had a financial data, we had external market data, then we have a demand data. Okay, so what is the demand data? Okay, what is the demand data? So we had all this different data. I just put some sample data here. Okay, I just put some sample data. So why do I need time data? So the time data basically tells me per hour, per day, whether it's a holiday or it's a weekday or seasonal, etc. I do need to know that one. I do need to know that one. And whether, okay, is it going to snow today? Is it going to be hot today? How does the weather is going to look like? Because that also increases the demand. That also increases the demand because in New Year, a lot of people celebrate New Year. So that time the demand is going to be high. I need to know that one. So then the finite data, unit price. Am I going to give any discounts? Is there any promotion? Is there any capping, etc.? I need to know this one. Then location. Who's living in this location? Does the people in this location are rich or poor or middle class? What kind of people they are? Why? So someone can't afford to pay this much. Then, if people don't have, for example, rich people have bigger houses, bigger appliances, correct? Poor people may not have bigger houses, bigger appliances. That means the demand is less, the consumption is less. So I do want to understand the market condition. Then the demand data, address, correct, etc. So I'm not going to read all those things. So bottom line, what I'm saying actually, you have to get all these different data sets. Okay, so we understand the objective. Now we need to know what the different data. This is just an example. Okay, this is just an example. Okay? You have time data, you have weather data, financial data, external data. Then you have demand data. Like this, it's just an example. So here I have by year, by month, by week, by date, hours, I can see how much has been used, correct? So it's a residential customer, this is the address, this is the measurement, correct? So I can tell how much energy has been consumed, correct? So like this, I have all the data has been captured, okay? We capture all the data. And this is where we use big data and IoT. Big data and IoT, correct? So where we have big data and IoT comes into the picture, to collecting all this data, to bring the data sets together, to process the data together, to make the data available for the model to learn, correct? So this is basically one of the things that what we did. So now what I have 36-month data, 68 fields, 42 features, correct? So in the energy demand forecast, for the energy demand forecast, so what are the different data sets we used? Okay, there is different data sets we use, correct? So I explained to you before, correct? If you see here, I have time, I have weather, I have financial and external market and demand data, okay? So if I take a look at, I have 68 fields in this one. Out of the 68 fields, which are the field we use for the machine to learn? That is basically features, that's about 42. How much historical data we use? 36 months, okay? 36 months. It is most critical for you to understand the data pre-processing. What is the data pre-processing? Okay, so before you basically bring the data to model to learn or do something, there are many different things you have to do. Understand the data sets, understand the data fields, understand the data analysis, correct? You see what kind of distribution, correct? So when I say distribution, you cannot have only residential data. You cannot have only industrial data. You have to have balance between these two. Depends on what's your problem. If you're forecasting for residential customer, then it makes sense. If you're forecasting for in general energy demand, then you need to know both, correct? So those are all things what I'm talking about, different data analysis that we need to perform. Okay, so we did perform data pre-processing. Once we identified what data we need, once after collecting the data, then we kind of come up with this approach of data analysis, data fields, data sets. Okay, so what is the source, from where, what data source is coming, what data fields is coming, what is subset, what's the missing values, and etc. Correct? All the things we performed. All right. Now, what we wanted to understand. So we wanted to understand a little more detail actually. So the data requirement, what we have, two key important concepts, correct? One is, I don't know how many people truly know when people simply talk data, they don't understand all the things, correct? So what I'm talking about, the data means here two things. One is a plan and a projection. Okay, that is one set of data. Second is the actual, correct? So we used both the data sets. Okay, we used both to train the model, to teach the machine. We used both the plan and projected data and also the actual data. Okay, and also the actual data, what exactly it means, correct? So plan, actual, forecast, it's important. Plan is basically your target. Okay, actual, what has happened. Forecast, when you are not able to meet your target, correct? So the plan is nothing but your target. How much energy I'm going to produce, or I'm going to consume. So if you want to understand in your language, correct, in the academic side, so the plan is to enroll 200 students in big tech, artificial intelligence, and data science course. All right. Did I meet the plan? Yes or no? Yes, you met the plan. That means you have 200 students. That 200 is the actual. Before you enroll, you have a target, correct? The target is you want to have 200. The 200 could be 500. Okay. It depends on how you set the target based on the market demand. Right now, so there's the, like, talk in industry, people who study data science, artificial intelligence will get jobs quickly. That is a talk. So that is the market demand. So based on that, you set your target. Now you start enrolling. Once you enroll, then the student count will go up, correct? So how many students we enroll? We enroll 200. Wow. But still there is more demand coming, right? So that is basically meeting the demand. In that case, I don't have to do any forecast. Okay, I don't have to do any forecast. Let's say my target is enrolling 200 students. How much I enrolled? Only 100. So what happened? There's no much demand in the market. People are not interested. So the 50 is the actual. So the 100 is the actual. So my target is 200. How much I actually enrolled? Okay, 100. So in this case, the plan is 200. Actual is 100. Now for the next following year, I don't want to set a target of 200. I want to reforecast. Instead of 200, I want to set maybe 125 or 150. That is the forecast. So forecast is nothing but adjustment to the plan, adjustment to your target. So what I'm trying to say, in order for us to forecast, okay, in order for us to forecast, so we have to have these three data sets. Okay, so when I say data sets, I'm talking about the data that what I looked at, time data. I need plan, I need actual, I need forecast. Whether I need plan, I need actual, I need forecast. Financials, I need plan, I need actual, I need forecast. That is the point I'm trying to make you understand. So if we want to teach the machine, where the machine can understand what did you forecast, what's your target, what is the actual, what is the forecast, right? So that the machine, once it's understand the pattern, okay, so this is your target. The target was 200, actual was 100. I'm reforecasting for the following year 125. Okay, my target was 100, but the actual is 500. So now I'm going to reforecast, right? So based on what my actuals are. Okay, so this is basically how I want to teach the machine. So in order to make the machine to learn very effectively, in each of this data, I need three sets. Set one, actual. Set two, so let's start from plan. Set one, plan. Set two, actual. Set three, forecast. So that is the best way to learn. If you don't have the data, the model prediction won't occur. The model prediction won't occur. Even if it occurs, the accuracy may be questionable. The accuracy may be questionable. Having this will truly have full control on how the model is performing, how the model is predicting. Okay, it doesn't matter what algorithm you write. It doesn't matter what you teach. If the underlying data does not have any meaningful insights, if the model is not able to learn anything from this one, then no matter how hard you try, what you do, your prediction is not going to happen in the way that you're expecting. The model behavior is not going to be the way you are expecting. You may not achieve your desired result. So what we learned, so in order to implement the energy demand forecasting, we identified what data we needed. We also learned we need planned actual forecast data. We need planned actual forecast data. So that is a key point to understand. So this is just an example. Okay. So when I say test data, there is a plan, and then there's a test data, there's an actual. There's a development data. Okay. So that's a planned data, and there's an actual data. And then there's a training data. Correct. So what I'm talking about, when you want to teach, train, deploy a model. So you have training data to train the model. You have a development data, which is going to help you to build the model, and the test data, see how the model is performing. Okay, the accuracy, confidence level, all those things we used both. Okay, we used both. We used the planned data as well as actual data. So that is the point. All right. So this is, I'm sure you know, I'm going to quickly run through this. Okay, so you can understand. So traditionally, how we do forecast. Okay, let's not worry about. So we understand what is involved. Correct? Like, you know, what are we trying to achieve? We are trying to do energy demand forecast. We are trying to do energy demand forecasting. How much energy we need to produce, or we need to generate. Sorry, we need to generate. So that is what we want to forecast. So for that, we understand what is the business objective. We understood what's the data we need. We understood the type of data we need, which is planned, actual, forecast. Planned, actual, forecast is important. Okay. So now, what is the forecasting technique we want to use? Okay. So these are all traditional approach. Okay. It is not a machine learning model. Okay. So I'm sure you may have heard about it. Correct? So typically what people do in industry, in the place where I worked, so it was heavily used data-driven quantitative time series approach. Okay. So it's basically looking at the data over a period of time and then come up with some approach. Correct? All right. Last year, January, we used this much energy. Maybe this year we also have come up this one. But last year, January, there may not be a weather issue. But this year, January, there's a weather issue. So whatever you had last year, it may not be applicable this year. Okay. So a data-driven approach is more for looking at what happened in the last year, last month, follow the same thing. Okay. It is not a machine-driven approach. The second, typically what people do, an executive or an expert judgment. Correct. I'm very sure this is how much I'm going to do. So maybe some senior people or a senior management person can tell this is how much energy they're going to consume. So these are the two approaches traditionally what you see in the energy forecasting or any forecasting technique, either a data-driven approach or people approach. Okay, people typically use moving averages. Correct? So they look at last 3 months and see how it's going to be the next 3 months. They look at last 6 months, they see how the next 6 months is going to see. But what is missing? The other information, correct, such as the factors, the locational factors, environmental factors, correct, things that are going to impact majorly on that location. They don't consider all those things, correct? In a moving average, all you're looking at how much energy has been consumed or produced for the last 6 months, 9 months, 3 months. That's all you're using. You don't consider any external factors, correct? If you see what we have, an external factor, correct? An external factor, the location, okay, societal, who was living there, their economical things, okay, and what event occurs, okay, what event occurs, correct? And weather factors. They don't consider these things. Okay, so what I'm talking about in a traditional energy forecasting, whether it's a data-driven quantitative approach or a people-driven qualitative approach, you don't consider these factors. Which factors? I'm talking about weather factor, external market factors. You just simply look at what has been consumed or what has been produced for the last 3 months, 4 months, 6 months. Use that and make an expert judgment. And that is what happening 99.9% right now. We don't want to go that approach. We want to use all the factors, such as weather factor, external factor. Then it becomes very complex. Okay, what is complex? How do we get the data? How do we know what is inside? That is where data science comes into picture. You have to extract the hidden insights on weather. You have to extract hidden insights on the location. What is there in the location? People economical status, people living lifestyle, people using appliances. All this matters. All this matters. How do you extract? That is where you need machine learning models, data science, big data, IoT. All these things comes into picture. All right. So now we understand there is a traditional approach. Now let's move on to a machine learning approach. Okay. So we decided to move on to a machine learning approach. So what did we do? We want to implement time series analysis. I'm sure you all know what's time series analysis. Looking at data on a defined time interval, either daily, monthly, weekly, quarterly, yearly, whatever it is, right? You're looking at the data on a timely interval and see what's happening on the time frame, right? So we want to go and implement machine learning models. Under machine learning models, what did we do? We implemented time series data analysis. Okay, I have two options. Option A, use the pre-trained machine learning models. That means the model is already built. The model is already built, I can use them. All right, so what model that would be? An ARIMA model. I'm sure if you could Google on YouTube, you'll get to know a ton of resources on ARIMA. People have done this one. It's been around quite a while. So one option is I can use a pre-trained machine learning model, ARIMA. Okay, so ARIMA stands for Auto-Regressive Integrated Moving Average, correct? Auto-Regressive Integrated Moving Average. So that is a pre-trained model you could use. The second option could be in a custom model, something that you can build from scratch, such as either linear regression, neural net, and etc. Okay? So you have two choices to make. If you decided to go, correct? Option A, you go with the traditional approach. If you want to do a demand forecast, you can do a data-driven quantitative approach. Second, a people-driven qualitative approach. What is the problem in these two? These two does not look at factors such as weather factor, external factors, correct? Why? So this is very heavily driven by people and very simple methodologies. Now I want to go and use the weather factors and external factors. How can I deal with this? Then I need a different approach. What approach? A machine learning approach. So what is the technique that I'm going to follow? Time series analysis. What option I have? Two options. Option A, use a pre-trained model. Option B, build something from scratch. If you want to go for a pre-trained model, what model that is exists? The most common used model, ARIMA model. Auto-regressive, integrated, moving average. Okay? So other option, I can go and build a custom machine learning models. What is the custom machine learning model I can build? Linear regression neural network. Okay. This is just an example, correct? How did the forecast took place, correct? So you can see data has been distributed in equal time intervals, yearly, monthly, daily. Okay, that's just an example. So here I'm talking about what I wanted to find out from the data, whether I see any trend or seasonality, irregularity, and cyclic patterns, correct? So these are the patterns that machine wanted to understand, correct? So what do I see in the data sets, correct? Is the energies, is there any trend up and down, up and down? Yes, I do. Seasonal, there is a particular season, such as during summer, during winter, during Christmas, during New Year, there's a heavy energy is being used, correct? That's a seasonal. Irregularity, there's no reason, correct? So it happened in a random manner, correct? Someday it happens very high, someday low, someday high. It's kind of irregular. Cyclic, I can see a pattern, correct? So first week, okay, second week, average, third week, high usage, correct? First week, an average week usage, medium usage, and a high usage, then again it repeats. And so average, medium, high. Okay, every week I see a cyclic pattern. Okay, so like this, you wanted to understand all different type of usage patterns in the data sets. Okay, I want to understand all different type of patterns in the data sets. In a time series data, what type of data distribution and what analysis we can see. This is what we see. So we can look at in the time series data, a trend, seasonality, irregularity, cyclic patterns. Okay? How energy is being consumed, how much energy is being produced based on a trend, based on a seasonality or irregularity cycle. Trend, we can, it's basically the trend is going up, up, up. Okay? So week 1, okay, 100, week 2, 200, week 3, 300. That's the trend I see. Seasonality, it happens on a particular time interval, either Christmas or a New Year or a summer or a winter, like that. That's a season. Irregularity, no reason, correct? It always up and down, it's unpredictable at this point, right? It's irregular patterns, cyclic patterns. So you can analyze data. You can find out all the things in a time series data, okay? In a time series data, that's what I wanted to say actually. All right, so all the things I already told you. So this is an example of trend, okay, going up. This is an example, seasonal. So we told you one particular season, it's going up, then it's coming down. And then this is irregularity, an example. All the things you can see in our energy and demo that I showed you. So in the Google Data Studio, the thing that I was showing you. So here we have all the things. So this is basically the screenshot that I put in there. Okay, so this is a screenshot that I put there. All right. So now what I wanted to talk about it. So this is basically what we wanted to implement. Okay. So I'm sure some of you already know this one, so I don't need to go. So in order for you to make the machine to learn and understand, okay, whether we want to implement like a machine learning model in the time series and data has to be stationary. Okay, so how do you make this? There are two options: rolling statistics or an ADCF test. So these are all basic things. I'm sure you can understand this one. So I have limited time. I'm just going to skip this right now. Move on. Okay, so what model we implemented? I told you there are two options. Option A, you can use a pre-trained model. Option B, you can use like your model that you can build from scratch. So this is a way to implement the RMP model, correct? So auto-regressive integration, moving average, correct? There are two different models and integrated together, correct? So the goal is what? The goal is to find out, okay, how much energy I'm going to produce. For that, what model we used? This is the model we used. Okay. So the model implementation, I have the source code. I can take it as well. Okay. So if I don't want to go that model, correct? If I don't want to go a pre-trained model, what option I have? I have an option to build a model from the scratch. So there are three different options. You can use a pre-trained model or a transfer learning or model building from the scratch. Okay, model building from the scratch. A pre-trained model, you may not be able to change those models, correct? So that's already been well set. Okay, you may not be able to change the model. A transfer learning, there is an option for you to, okay, you can just transfer the learning, then you can maybe like modify the model by doing your own development data and training data and etc. So there is an option to make a change. The third option is building model. So what I'm trying to say, correct? If we wanted to implement correct machine learning models, what options I have for the energy demand forecasting? There are three options. One is you can go with the pre-trained model, which we looked at, the RMP model. It's already trained. You can use this one. Second, the transfer learning. Third, building models from the scratch. Right? So this is what we learned about, like energy demand forecasting, time series analysis, building models from scratch. Okay, so when you go for building models from the scratch, there are two options. You can implement a simple supervised machine learning, which is a statistical based learning approach. The second is deep learning model, RNN, which is a recurrent neural network. Okay, so there are two options. You can follow this one. So this is another option to implement. Okay, so this is basically like how we want to implement the recurrent neural network. Correct. So what I did so far, I walked you through the process that is involved in the energy demand forecasting, different data that is required, and currently how business is doing these kind of forecasting. When we look at machine learning models, what options we have? So we can use a pre-trained model. You can use a model that is something that we can build from scratch, right? So what is the pre-training model that we have for this one? The RMP model, that what we looked at, right? So the next option, something that we can build from the scratch. That means I can implement a statistical based learning approach or a neuron based learning approach. What is a logistic regression? So this is basically like so what we talked about. Sorry, the statistical based learning model is the linear regression, and then the neuron based learning is the RNN, which is like recurrent neural network. So now let us go to the actual model implementation. So this is just to set the context for you to understand the problem that what you are taking, data that is required, and the challenges that is involved, what options do you have to build the machine learning models. So now let's understand how do we build this one. Okay, now let's understand how do we build this one. So like I said, I also have the source code. You can also look at it. Okay, so you can go from there. So this is the actual implementation of the RNN model. Okay, so actual implementation of RNN model. I'm just going to quickly run this through. Again, all these are all quite intense, lot of different topics to be covered. So let's assume we decided to go ahead and use deep learning to do energy demand forecasting. Okay, so this is the underlying problem statement. So once we have a problem statement, the model selection is a deep learning. What model we selected? Recurrent neural network. That's the model we want to implement. Okay, so once we understand we are going to implement a deep learning model, what you have to do, you must have to understand all the different building blocks of a deep learning model. Without knowing this, it is impossible for you to build a model. Correct? So understand, we are going step by step. Correct? So define the problem. Okay, so understand the problem first. So that is what the context what we did. So once we understand the problem, then we're going to do a model selection. What model we are going to do? We are going to implement a deep learning model. What is that model? RNN. Okay, all right. Now, if I want to implement RNN, what exactly I need to know? Okay, what exactly I need to know? These core building blocks. Without this, It is absolutely impossible. Absolutely impossible. We need to know what is neurons. What are the different layers? Input layer, output layer, hidden layer. What's weights? What bias? What's an activation function? Forward propagation, backward propagation, cost function, gradient descent. Correct. So all the things absolutely must. Not a theory. How do you implement this? How do you implement this? That is what needed. That is what needed. Okay. So someone raised the question. So I will answer. I'll take your question in 5 minutes. Okay. I want to just quickly run this through. All right. Now here, okay, I'm just giving an examples. Okay, I'm giving an examples. In a deep learning model, okay, the neurons acts like a human, correct? It understands. How do I know what is a demand, correct? How do I know the demand, correct? I can look at the patterns in the data, okay? How much is produced Monday, 6 o'clock, 7 o'clock, 8 o'clock, etc. Tuesday, like this, I can see and understand. Similarly, how do I teach the machine? And that is basically like, the machine need to understand the key features, correct? The key features, what the machine is going to learn. That is an important factor. If you see one of my slides, we had used about 42 features, correct? So 42 features. So that is really important. That is really important, correct? So that is really important, okay? And this is different. How many input layer I need? How many hidden layer I need, how many output layer, kind of like this, I have to come up with all the things. For example, I have different data sets. I have time, okay, I have a location, I have like an electricity cost. All these are all what? Different data, okay? And this is going to basically go through this process, okay? And then come up with like, energy demand this much, energy demand this much. So here in neurons, basically like, it's almost like, how we as a human analyze data. It's going to analyze this one. So we do have to understand all the different things, correct? Without, like I said, without knowing this, correct? Without knowing this in a very clear way, not a theory, not a concept, in an implementation level, you will not be able to build any model using deep learning approach, correct? This is very critical, correct? So that is what I'm trying to explain, correct? So how does the model understand what is the different feature? It learns from the data. Okay, so same for it trying to take all the different features, correct? Location, time, energy, this, that, then it come up with like the input layers. From there, hidden layer, go to an output layer, come up with this one. Correct? Same thing. Okay, so I'm just saying that like the steps is involved. So in our case, what we have in the source code, we have an INA file, which is basically tells the different things that what we do in terms of like where the data is coming from and any other external functions that we call and do this one. Then next is we are going to import the required libraries, then importing the training data, and then creating the model using like libraries, and then train the model, and then test the model, and run the model prediction, write the model outcome to a file, and then be done. So this is high level steps that I'm talking about. This is the high level step that I'm talking about. So I just wanted to tell you that if anybody wanted to go deeper into this one, we do have, like I said, the source code, correct? So people can go and understand this one, correct? So both the ARIMA model as well as the RMN model that what we implemented, we have the source code here. You can see this one. Okay, so you can see this one. So this is basically step by step, everything is explained here. You should be able to understand, correct? So all the use cases, it's in our GitHub. You can understand this one, and it has everything. Like for example, any use case that you take. Okay, so retail energy. 1 second, I'm just looking for the one that. Just a second. Okay, so we clearly differentiate, like so this is a deep learning model. So here you can see the problem statement, what data we used, what is the model architecture, and in terms of like model source code, model outcome. So everything that what I talked to here, it is there. Okay, so if you wanted to understand, the problem statement, like it is there actually. So if any model that what we used, training data is there. So all the things, it's now GitHub. Okay, so if anybody is really interested to learn this further and wanted to implement this one, okay, definitely there's more option to learn, implement, understand deeply. It is there. We already built. So this is what I was talking about. So when you go to the source code, you will see the actual source code. Okay? You will see the actual source code. So this one has the implementation of the ARIMA model. Similarly, we have RNN model. So as needed, we can provide. So we have explained everything step by step. Import the library. Once done, and import the required libraries. Like, so this is basically like, so any library that we need, we will import them actually. Okay. And then we have the training data. Once we done the model, once we import the model, we train the model. Okay. So then run through this process. Okay? So I'm just saying all the steps that is required, it's here. Okay. So this is basically gives an idea. Okay. In a country, state, city, how much energy is being forecasted. Okay. Demand is being forecasted. This is just an example. All right. So like I said, in a 1 hour time covering all, it's going to be not an easy topic. I try my best and I hope you found this to be useful. Anybody who's serious, sincere, who want to make a true attempt, you can contact me. Okay. We'll go from there. So I think that's all I have. I'm going to stop here and take any questions if you have. Please feel free to bring any questions you have. We can discuss. Thank you very much. Any questions?
Thank you so much. Thank you so much, sir, for such a delightful and enlightening session. A gentle reminder to all the participants, kindly fill in the feedback link that has been posted in the chat box. And also you can unmute yourself and ask your queries.
Yes. If there's any question, please bring it up. We'll discuss.
Hello.
Sir, good morning, sir.
Yes, sir.
This is Dharmadevi from Sacred
So
College.
Google, yes, I can see a question. So what is the purpose of Google Colab? Google Colab we are using because we have different developers. So we use Google Colab more for developing our source code. Correct? This is more for like if you want to install your own Jupyter notebook or your own development infrastructure, you can do. Since we want to have a collaborative development infrastructure, so we use Google Colab for a collaborative development infrastructure to develop the source code. Like we have installed all the runtime libraries like Pythons and also Anaconda, Jupyter Notebooks, Scala, everything is running there. It's primarily for distributed computing and collaborative development effort.
Sir?
Yes, any other questions?
Hello, sir?
Yes,
Is my
sir.
voice
Yes, sir.
audible?
Yes, sir. Yes, sir.
Yeah, first of all, it was a wonderful session, sir, to listen to you. Very informative. I have already posted 2 questions. First is how much domain knowledge we need to have in order to be in the field of ML or DL first. And second is it true that we use ML for structured data and DL for unstructured data?
No, sir. First of all, I would suggest, like, as I told you in the class, in the session, that, like, do not compare ML and DL like that. Okay? Machine learning, it's a concept. Okay? Machine learning basically does not dictate any underlying architecture. It does not dictate how the machine is learning. Machine learning simply tells it's an art of teaching, training, deploying machine. It's a concept. So what do you have to ask? Okay, you have to ask yourself the difference between deep learning. There are 2 approaches to train the machine. Approach 1, use statistical learning methodology, learning technique, such as decision tree, random forest, logistic regression. These are all statistic-based learning methodology, how the machine is learning, correct? So that architecture is different. Second is deep learning. Under deep learning, how the machine is learning, the architecture is different. As I explained, under deep learning, the machine learns used neurons. When you want to go and teach the machine using neurons, the architecture components such as neurons, input layer, hidden layer, output layer, correct, weight, bias, etc., all completely different. So the real difference is statistical-based learning methodology, neuron-based learning methodology. Under statistical-based learning methodology, you have supervised, unsupervised reinforcement learnings. Typically, people use this. Under neuron-based deep learning, so please do not compare ML and DL. This is how 99.9% people are speaking, which is wrong, correct? So there is no such things called ML. Everything what I talked about, whether it's a statistics-based learning approach or a neuron-based learning, which both falls under machine learning. Both falls under machine learning. What does that mean? How you teach and train and test and deploy machine. That's all machine learning does. It doesn't tell any architectural components, correct? That's point 1.
Coming to whether the structured data means machine learning, unstructured data means, or a complex data means deep learning, that is not true. Okay, so in both the cases, whether if you want to go for statistics-based learning approach or a neuron-based learning approach, when you go for neuron-based learning approach, that's where deep learning comes into picture. Whether it's a statistical-based learning or a neuron-based learning, in both the cases, you can use structured data as well as unstructured data. For example, customer sentiment, correct? Very simple example, customer sentiment. To build a customer sentiment, you can implement a simple, like, whether the customer is going to like this product or not, whether the customer likes my company or not, correct? I want to predict that. I want to analyze this one. I want to do this one. So that could be a Twitter data. That's an unstructured data. So that could be run on a simple random forest, or you can build a neural net, correct? So random forest, if you take it, it's a statistical based learning approach. Okay, neural net is a neuron based learning approach. Correct? Both can work in an unstructured data. So there's no like clearly defined guideline or a approach saying that if you wanted to use like structured data, that means you will be using statistical based learning approach. If it's unstructured data, it's a complex big data, sensor data, then use like deep learning. Nothing like that, kind. It's based on the problem, based on the situation, based on what you're trying to achieve, kind. So, and the problem is the one drives what model to choose. Then the type of data dictates how to approach these things, kind. So I would not simply say that if it is structured data, then use statistical based learning. If it is unstructured data, use deep learning. I would not say that.
Yeah, thank you, Jyoti sir.
Yes, sir. Any other question?
You just mentioned that whoever is interested to work on this project. So, like, could you please repeat that statement?
So, if what I demonstrated an ARIMA model, like basically a pre-trained model which is already built. We use that model to do a demand forecasting. There is another option I told. You can also build a model from the scratch by yourself. We don't need to use somebody already built, correct? So I don't want to use someone already built, correct? I want to go and build and learn for myself, such as I want to implement a simple statistical based learning model, linear regression, correct? Using linear regression, also you can do demand forecasting. You can also use deep learning models such as RNN to do a demand forecasting. So what I'm saying, that model I did not demonstrate or walked you through in the class, correct? In case if anybody interested to implement this one, I can have more in-depth discussion on that particular topic of implementing a demand forecasting using a statistical based learning model such as linear regression or a deep learning neuron based deep learning model such as RNN. If anybody interested, we can talk further. That's what I meant.
Sir, I have a question.
Good morning, sir.
Yes, madam.
Sir, is that data studio freely available for researchers and users?
It is not a free, it is a licensed product. All our products are built on Google Cloud. So we have an enterprise license. So it's a licensed product. It's not free.
Oh, thank you, sir.
No problem. So, but Data Studio gives access to, one second, madam. Data Studio gives access to any data. More than, I would say you can access more than 100+ data sources. You can connect to read sensors, you can connect to read device level information, you can connect and read like images, voices, sky is the limit. You can bring any data together. Yes, ma'am, sorry.
Yes, sir. So first of all, I thank you so much for your excellent presentation and clear explanation, sir. You got a very insight into the ML. I'm doing research in ML. So could you suggest the mathematical knowledge we need to develop our own models. Or to give our research contribution? Sure, what are the mathematical courses we need to learn? Actually, when I referred, I gone through so many models are there as you are explaining like that. But in order to do your research, we need to do some contribution in that. For that, what are the mathematical things we need to learn for our contribution, sir? So, like I said, I may not be able to add much value from the academic side, but I can share from my side, correct? When we build models from the scratch, correct? Let's say we have a problem, we don't have a model readily available. We have to build from the scratch. And some cases, we also have to fine tune the model, how it behaves and does. So in that context, the knowledge that what we use actually from mathematical functions, linear algebra, vectors, and calculus, correct? So those are the things
primarily in a key area that we focus in terms of whether we wanted to understand deeply how the model functions based on the algorithm that is created underlying. And if you want to go out and build and optimize this one, so what mathematical concept or technique that we applied or used, learned, it's linear algebra, calculus, and vector. Those are the three things. But again, I'm not a mathematician. I won't be able to comment from the academic side. But if there is a particular problem, let's say you are building a model, it's not performing well, or the desired outcome is not able to achieve under all circumstances, that I can troubleshoot. Okay, that I can troubleshoot. But going
Thank you,
deeper
sir.
into
Thank you.
yes, ma'am. Going deeper, I may not be the right person.
Okay.
Maybe you can check with Dr. Dilip.
Okay, sir. Thank you, sir.
All right. Any other questions? All right. Yes, ma'am.
Thank you, sir. It was really wonderful session, and thanks a lot for answering all the questions. Now I would like to invite Mr. D. Rajkumar, Assistant Professor, MCA, to propose the vote of thanks.
Good morning,
Sir.
everyone. It is indeed my great pleasure to propose vote of thanks. So as always, sir, your presentation was very nice, especially in understanding what is the exact difference between this machine learning and deep learning. As you said, the concepts were very clear, sir. And thank you for this wonderful explanation about how energy forecasting is done. Okay, it was especially a new concept for us, and thank you for an explanation right from the concept of how we should plan and how we should manage the demand and what we actually need. And thank you for showing us the demo in which DeepSphere have developed this wonderful product for performing this energy forecasting, sir. Sir, we thank you once again on behalf of our institution, our HOD, and our department, and especially on the participants' behalf. It was a very wonderful session for us, and it was highly informative, sir. Thank you so much. Thank you, sir.
Thank you, sir. I want to thank you, Dr. Dileepan, for the opportunity. Thank you, sir. Take care. Bye.
Thank you, sir. Thanks a lot. Dear participants, tomorrow the session will be around 5 o'clock, and the chief guest is Dr. Ramalingam Chellappa from University of Maryland, USA, and the topic is design of fair, robust, and interpretable AI systems. So we will join tomorrow around 5 p.m. for the session. Thank you, participants, and kindly fill in the feedback that has been posted in the chat box. Thank you.